What's up, math scholars and math haters? This is Mr. W. We are going to continue looking at probability by actually, this time, getting into the basic idea of probability itself. Now, every study of probability comes from this one idea that when we look at probability, we're looking for one particular thing to happen out of a group or a set or a space of possibilities. And I'll go over a couple examples of what this could look like, but essentially, the probability of a particular thing happening that we're interested in is the number of ways that thing can happen over the number of total possible outcomes. And I know my handwriting there is horrible, but it's the number of ways that that particular thing that we're interested in can happen divided by the number of total possible outcomes. And we can write this as a fraction, or we can move on to call it a decimal or even a percent. You might see any of these representations when you do a probability question. But for right now, let's get to our first example. And here's our first example, a spinner. One of like the stupidest ways to study this, but here we are. So we have a spinner, and we're supposed to find the probability of it landing on a few different colors, a few different combinations of colors. So let's go ahead and start by the probability, or by finding the probability that it lands on green. So there are two sections that are green, and this is going to be out of 8 sections total. So our probability, we could say, is 2/8, also known as 1/4, also known as 0.25. So we have the original fraction, a simplified fraction, and then a decimal version. And then if we want to call it a percent, we can do the hopping the decimal 2 places to the right trick and end up saying that that's 25%. Now, for it landing on red, there are 1, 2, 3 red sections out of 8 total sections in this spinner. There's no way to simplify that, but I will go ahead and write out the decimal form, which is 0.375. Now down here, the probability of landing on yellow, as we can see, there are no yellow sections. So no matter how many times we spin the spinner, we will never ever land on yellow. And I will go ahead and say that that probability is 0 or nothing, or however you want to think of that. Now to this section, we have some OR words, or we have some OR events. So in the example of red or green, we're okay if it lands on any of the 3 red sections or any of the 2 green sections. So that's 5 ways to get what we want out of 8 total outcomes still, and we can call this 0.625. Next, we have the probability of landing on a primary color. Primary colors are red, blue, and yellow. There's 3 red sections, 1 blue section, and no yellow sections. So that leaves us a total of 4 ways to get what we want out of 8 total possibilities, also known as 1/2, or a probability of 0.5. And finally, we have any color but blue. Now, this is a good example of what's called the probability of a complement, because if I can look for my blue sections, I can see that there's just 1 out of 8, which means that if I want to land on any color but blue, I can take the whole fraction or the whole decimal, which is 1 or something like that. I can take 8 out of 8, subtract 1 out of 8, and I end up with the number of sections that are not blue. 1, 2, 3, 4, 5, 6, 7. So that's the idea of the probability of a complement. We can call it 7/8 or 1 minus 1/8 or something like that. But either way, there's our fraction, there's our decimal, there's both of the big representations of this probability that we will need. Now the next example probability situation we'll work with is rolling 2 number cubes, or 2 dice, at the same time. Now if we want to think about the total number of possibilities, by the fundamental counting principle, we can multiply the number of ways to roll the first one, which is 6, by the number of ways to roll the second one, which is 6, to get 36. And if you look closely, you'll see that we have some duplicate sets of numbers here, like 1 and 3, and then 3 and 1. But keep in mind, 3 and 1 is what would happen if the first roll were a 3 and the second roll were a 1. And then this 1, 3 up here is what would happen if the first roll were a 1 and the second roll were a 3. So there are two different ways to get that combination of 1 and 3 because we have two dice. So now, to go ahead and find some probabilities, first we'll find the probability of rolling two even numbers. Now, in order to find where we're rolling two even numbers, we basically just have to look. That's a good space. That's two even numbers. That's that, and that. That's 9 total ways to get two even numbers out of a space of 36 total possibilities. This can simplify to 1/4 or 0.25. Now next, we're looking for the probability that we get two odd numbers. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9 ways to get two odd numbers. Still out of 36, and for the sake of space, the simplified fraction and the decimal representation will turn out to be the same as for two even numbers, so I will not go ahead and write those. But now, two numbers that add to 6. So essentially, I'm just looking for any combination of numbers where my two dice, when I roll them, add up to 6. So that's 1 and 5, that works. 2 and 4 works. 3 and 3 works. 4 and 2 works, and then 5 and 1 works. So there's 1, 2, 3, 4, 5 ways out of 36 to get that. And that is going to end up equaling, let me get out my calculator. Five out of 36 is 0.13 and then 8 repeating. Sorry, I just realized y'all couldn't see that. 5 possibilities out of 36 total equaled 0.138, and the 8 is repeating. And now we're looking for two numbers that add to more than 7. Now, an easy way to split this up is that this diagonal here are all the possibilities of combinations that add up to 7. Anything in the bottom right corner is going to equal more than 7. Anything in the top left corner is going to equal less. So anything that equals more than 7, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So basically this little staircase and anything in this area is going to add up to more than 7. So that's 15 ways to get more than 7 out of 36. We simplify that fraction down to 5/9. And the decimal representation of that is 0.5 repeating. So now over here we have either a total of 2 or a total of 12. Total of 2, that's just 1 and 1, that's the only way that can happen. Total of 12, that's 6 and 6, that's the only way that can happen. So that gives us two possibilities. Two ways to get this out of 36, also known as 1/18. And the decimal representation of that is 0.05, where the 5 is repeating. So now, we're looking for two numbers that add to less than 13. We can see from the last problem that 12 is the biggest number we can get from this. And if 12 is the biggest number, then if we're trying to add up to less than 13, then that's going to be everything. So that's 36 ways to get what we want out of 36 total possibilities, and that equals 1. Now here, we have two numbers that add to more than 12. This is kind of the opposite of the most recent problem, the less than 13 problem, because if we're looking for numbers that add to more than 12, every combination we can see here is going to add up to some number between 2 and 12 inclusive. Nothing is more than 12. So So there's no ways to get that out of 36 total possibilities, giving us a probability of 0. So that's a quick review of the basics of probability. Just remember, it's always how many ways there are to get what we're looking for, to get what we want, the particular event that we're interested in, divided by the total number of possibilities and possible outcomes.